Hi, this is Jay Bolding. We're going to spend a few minutes and talk about Revit structure, box truss, and space truss creation. So if you do a search online for box truss or space truss, you're going to find a lot of stuff. You're going to find a lot of images, but you're not going to find a lot in the way of Revit. What are we talking about when we talk about these space trusses or box trusses? Well, you can see here I've got a triangle sectioned one, so this one has 3 chords to it. And then there's other ones here that I have which have the 4 chords to them. So I'm going to flip over to the main 3D view, the default one, and we'll just take a quick look at these. So what these are using is just the basic beam and brace family, and you can, with that family, you can create something like this. They create their, for instance, their K-bar joists, and you can do all these shapes with them. So for instance, just to draw a straight one, well, that's easy enough. You can just go to Home, Beam, and just draw, pick points, and you're there. You can also change the height of the ends. So that's something which is not really new. But with these guys here, you might not know that if you go to an elevation view, and if you were to just activate the beam command, and I'm going to just use this triangle space truss, and we're going to put this on grid A, and what I could do is draw any shape, including a spline, and I could just say from there to there to there, and it will take a little bit more computing power to get this to happen because it's doing quite a complex calculation here. So now if I just flip back over to 3D again, and I'll just isolate that element, so you can see there that it created a space truss. Now I could swap that out. So I could say let's swap that out for a 1000, 1 meter by 1 meter box truss. So there's lots of different designs on these types of objects. And I just did one, really more of as a proof of concept than anything. But you could apply what we're going to be doing to virtually any shape that you need to add in here. Okay, or many shapes anyway. So what is this? Well, let's look at the family. Again, we started with the beam and brace family template. Okay, so just going to flip over here to one of the families. So there we are there. That's the box truss. And maybe I'll just go one more. This is the triangle space truss. And what I was aiming for here was one object which would be arrayed, and that's exactly what happened. So if we were to just deconstruct this a little bit, I'm going to delete some of the objects in the array, and I will also ungroup this family right here. So when you first open the beam and brace family template, you basically get one example. They just have like a square or a rectangle box going back like this. And what I do is I erase that and then draw in, if you go into the, let's say the right elevation, just draw your chords, whatever shapes those are, you can draw those in. I drew them all in as one extrusion. And then as another extrusion, I drew this, and this is going to represent the webbing. But you can see here in the 3D that the webbing is solid. It's not, there's nothing taken out of it yet. I tried also with actual elements, and if you look at the K series bar joist, that's exactly what they've done, is they made a special family that it just adds in the little web pieces. But I'm finding that on angles especially, it's extremely difficult to work with the planes. So this is a little bit more of an accessible option. Okay, so we can put in this void family, and I will explain how to make that void family in a second. I just want to show you the results from it. So if I go to component and then I just drop that in, you can put that in. Now I can click on this little void family and spin it around. So you can see that wherever it's going through this is its host, this web, it's going to cut through it. So if I go to, let's say, left elevation, there it is there, but you can see that it's a little misaligned. So I'm going to try to align this. And you can do this in any one of the views. Probably to start out in the reference level or the floor plan is the best. So what you can do is just align that to that, constrain it, align that to that, and then constrain that. Good, and then let's go to 3D and see if that looks good. Okay, so for this particular design, that's going to be fine. Again, there's lots of different designs of space trusses. So now I can go to what they call the front, and this is where we could array this. Okay, so I'm going to go in here and select that void. I'm going to select that family and make sure that that's all I have. Yeah, that's all I have. And I'm going to array it, and I'm going to go to the second. So I'll just go from there over to there. And then I'm going to align them both up, and I'm going to constrain the second there so they kind of know that they have to go in a row, always be connected, so there's not a little, wrong piece of webbing in there. Okay, so once that's done, you're really all you're going to get is that as your web. So the rest would be all solid. So you need this to continue the length of the object. So what you can do is click on the array, click on the little array dimension, and you can say, let's add a parameter. I already did this. I called it web array. And what it does is it takes the length. Let's just go into the properties here. So it takes the length divided by the base width. And the base width is the width of the array, so it's the width of this little object right here, one of those bays, as well as the size of the space truss. Okay, so then you load that in. Now, how did I make that little void family? Well, I'm going to just flip back over to that. Okay, so here's the example of the void family. So what it's doing is it's cutting this way, so from the sides and then from the bottom. And then it doesn't need to cut anything at the top because it's a triangle. So basically all of this is almost used like as a tool to cut. Anything left over will be solid. Now in order to make this and make sure that it actually cuts, you have to use I'll just show you the template that you need to use. It's a very commonly used template. So you just go to this face-based one, and you're going to get a little host. And the key here is you want to make sure that whenever you make a void object in here, no matter what, even if it's not actually inside the host, so let's say I have a void right here, and I'll just click on it and bring it right outside of it's outside of the host, as you can see. This has the ability to cut its host, but you have to tell it cut its host. Now, even though it doesn't look like it's cutting it, if it ever comes in contact with the host, it'll know to cut it. And that's how you get this thing to happen. So then you load this in. I showed you what you do from there. Now, if I just go quickly into the parameters of this, what I did is I had a width, a height, and a depth. And the depth is just right here. How deep is this bottom piece of the void? So how far down am I going to cut? And these guys are just locked kind of to the extents of this cube that I want to keep cutting through the truss. And I put a little formula in there, but really what happens is when you get into the family, so I've nested this, so I loaded into the actual space truss. I'll just go over to it. So if I put it in here, then I'm going to connect up. If I go into that space truss void, I'm connecting up the width and the height to the width and the height of this particular space truss. And you could go on and on with this. The more parameters you make, the more sophisticated, a little bit more complicated it's going to be. Okay, so just flipping back to our project. So this can be different sizes. I only tested it for 750 and 1000. You could make it a bigger size. So if I said, let's go huge, 2 meters. Okay, and then I'll actually change the height. So I'm going to go with the base width. That's the kind of the driving parameter right there. And then I'll say OK to that. Let's see what happens. Okay, so it sort of dug into the floor there, but it did make it. Now you may say, oh, but now the webbing is not thick enough, and yeah, those are all other parameters that you would need to build in order to design this according to whatever your needs are. Okay, so that's a little bit of a basic on how to create this type of shape, and I hope you found this useful.